Hi everyone. So I wanted to make a video connecting what we learned in Unit 1 when we were evaluating limits that gave us an indeterminate form with what we're learning now with L'Hopital's rule. And then I also wanted to kind of go back and talk a little bit more about the example that Dr. Lee just did. So let's start off with this problem. I've got the limit as x approaches 2 of x minus 2 over x squared minus 4. And this is something that we would have seen in Unit 1. And you can see that when we use direct substitution, we're going to get that indeterminate form of 0 over 0. So in Unit 1, we learned a few techniques like factoring, multiplying by a conjugate, or finding a common denominator that allowed us to deal with this indeterminate form. And for this problem, factoring makes the most sense. So if we factor this, we can see that the x minus 2's will cancel, leaving us with the limit as x approaches 2 of 1 over x plus 2. And now when we use direct substitution, we'll get 1/4. So the first thing I want to show you is that we're going to get the same result if we use L'Hopital's rule. So let's look at L'Hopital's rule. So again, I'm going to start with the same problem. And with L'Hopital's, we always want to make sure that we are getting that indeterminate form. And as you can see above, we'll get the 0 over 0. So L'Hopital's says that we can take the derivative of the numerator and the denominator and evaluate the limit, the same limit. So if I take the derivative of the numerator, we get 1, and the derivative of the denominator is 2x. And now when we use direct substitution, we'll get 1 over 2 times 2, or 1/4, and you can see that we're getting the same answer as we did when we factored above. So kind of the question is, why do we use L'Hopital's rule then if we had these other methods and they worked? Well, there's obviously lots of problems where factoring is not an option, finding a common denominator doesn't work, and there's no conjugate to multiply by. So I want to take a look at the example that Dr. Lee did. So we're looking at this one, and you can see that those techniques we learned in Unit 1 are not going to work for this. So I don't want to repeat too much of what he did, but you can see that when we used direct substitution here, we're getting 0 minus the natural log of 1 over 0 squared, and the natural log of 1 is 0, so we are getting that indeterminate form of 0 over 0. So we're applying L'Hopital's rule, and we're saying that this limit, if we take the derivative of the numerator and the denominator, the derivative of x is 1, the derivative of natural log is 1 over the argument inside, and then using the chain rule, the derivative of 1 plus x is just 1, and then we've got the derivative of the denominator. So right here, Dr. Lee said, okay, let's clean this up, and he found a common denominator. But why did he do that? The reason he did that is because you can see here that if you were to use direct substitution again, just as this is, you will have 1 minus 1 over 1 over 2 times 0, which will give you 0 over 0 again. So we have another indeterminate form. So our options with this second indeterminate form is to use L'Hopital's rule again, or use one of the techniques that we learned in Unit 1. So Dr. Lee used one of the techniques that we learned in Unit 1. He found a common denominator in the numerator and then simplified that complex fraction. And by doing that simplification, the indeterminate form factored out, and we were able to find the limit. So could we use L'Hopital's rule again? Yeah, we could. The tricky part is this 1 over 1 plus x. A lot of people don't like taking derivatives of something like that, but let's try it. So let's do another L'Hopital's rule, or let's use L'Hopital's rule a second time and see what happens. So I'm going to start off by writing this as 1 plus x to the negative 1 power so that I can use the power rule. And I am taking the derivative of the numerator and the denominator separately. We're not using any kind of quotient rule. So the derivative of the numerator, well, the derivative of 1 drops off, and the derivative of this minus 1 plus x to the minus 1 will drop that minus 1 down in front. It's going to cancel with a negative. So we'll have 1 plus x and then minus 2, and the derivative of the inside again is 1. And then the derivative of the denominator is 2. So this will leave us with the limit as x goes to 0 of 1 over x, 1 plus x squared over 2. Now let's try substituting in 0 for x, and we will have 1 over 1 plus 0 squared over 2, leaving us with 1 over 1 over 2, or 1/2, which is the same answer that Dr. Lee got in the previous slide.